All right, hello everyone. So I kind of just wanted to do a little bit of a video with you because I know it can be challenging doing math just looking at the lessons. So I want to kind of make some videos here and there depending on the lesson, just to discuss with you. But if you don't like these videos and prefer to just look at the lesson notes, and that's fine with me, I just wanted to do some videos here and there. And let me know if there's any that you want me to explain further. I can always do that. So today we're looking at 1.3, so this is graphically solving linear systems. So our learning goal for this is to use graphs to solve a pair of linear equations simultaneously. So we have been looking at different linear equations and how to solve them based off if we have a graph, a table, etc. So today we're going to solve this using graphs. So when we look at linear systems and we're trying to solve them, that means to find the point of intersection. Oops. I'm gonna just write on here. Point of intersection. So that means when we're looking at a linear system, that means we're looking at two different line equations. Okay, so when we're looking at them and trying to solve them, we can solve them by graphing both equations on the exact same axes. So the ordered pair, when we look at ordered pair, that's x and y on our axes, at the point of intersection gives us a solution to that system. So it's very, very important to always check your solution by substituting in your x and y values, and we talked about this yesterday in the lessons and the first lesson. So always substitute your x and y values from the coordinate to make sure that the left side is always going to equal your right side, because we need to make sure that both sides are equal with one another. So you may not always be able to determine an accurate exact solution of the system of the equations by using a hand-drawn graph. Because of that, sometimes things might be a little bit off or whatever it might be. So we do use a graphing calculator. So we can graph a linear equation from its equation in three ways, and we talked about these three ways yesterday. So the first is a table of values. The second is the slope and y-intercept. And that means we're looking at the y-intercept first, and then we're going to use the slope afterwards. Okay, and then last but not least, we're looking at the x and y intercepts. So remember that whenever we're looking at the y-intercepts and the x-intercepts always look at y equals to 0, and to find the y-intercept, we always let x equal 0. So that's very important to remember. So now we're going to do an example together, and I'm going to get you to do some examples on your own. So I'm not going to do all of them with you. I want you to take some time to look at the examples on your own, try them out, see what you can solve for, because it's going to be really important that you practice some of these on your own. So we're going to look at the first one together. So it says solve the system y equals 2x plus 1. So always highlight your important values, and x plus 2y equals -8. So always important to highlight your values. So we're going to start off, and we're going to number this 1, and we're going to number this 2, because we're going to solve for it, and we're going to kind of space it out a little bit. So our first one here, we have y equals 2x plus 1. That's going to be really important to remember. So when we look at our m in our equation, m is equal to our 2. And because it is 2, it doesn't mean it's not in a fraction. It's always 2 over 1. So this means that we're going up by 2, and then we're going to the right by 1. Both of that is positive values, so that's why we go up and to the right. We look at our b value. Our b value is 1. So therefore, if we're going to put this on a graph as our point, it's 0 and 1. Okay. Next, we're going to look at is 2, or part 2. So x equals, or sorry about that, x plus 2y equals -8. So if we're looking at this, we need to isolate our variables and solve. So we're going to keep y on the outside on the left, so we're going to keep 2y there. And we're going to move x over to the other side. So because of that, we're going to make it a -x minus 8. Okay, and we always know that just because it's an x, we know that in this case, I'm just going to change my color here, that x is always 1x. So that is something that we always need to remember. Now we need to isolate y, so we're going to divide our left side by our right side by 2. So both sides are going to be divided by 2, and we're going to isolate it so y is on its own. So once y is on its own, we can divide 1 or -1x over 2. It's going to stay the same, -1x over 2. And then we're going to have -8 divided by 2, and that will give us -4. Now, if we're looking at this, we're going to do what our m and our b is. So our m is -1 over 2. Okay, so that means if we're going to look at this on our graph, that means we're going to go down by 1, and we're going to the right by 2. You're wondering why the bottom number is not a negative and we're going to the right, because the negative always stays with the top number. And then for b is just -4, and we know that, so therefore our point of intersection is 0 and -4. So now your next step is to plot this on the graph. Okay, so using your information, you're going to plot this on the graph. For this, we're going to start with our first one, number 1. We'll use our blue to plot number 1. So in order to do this, we need to look at our graph. Our graph is a little bit wonky, doesn't have any lines on it, so I'm just going to draw a line quickly to show where our axes are. We don't really have an axis, so that's going to be our axes. I just drew it freehand quickly. It's obviously not going to be straight. That's why we use a graphing calculator. So in order to plot this, we need to have our 0 and 1. So our x is at 0 and our y is at 1. So we're plotting this point here. And then we know we're going to go up by 2 and to the right by 1. So up 2 to the right by 1, up 2, right 1. And then we can do the opposite in the other direction. Down 2, left 1, down 2, left 1. And you will take a ruler out and draw a nice straight line. I will not, because I'm freehanding it. Then you're going to do the other color for your number 2. So we're plotting this one as well. So our B is at 0 and -4. So plot that. And then for this, we go down 1 to the right 2. Down 1 to the right 2, up 1 to the left 2. And then once again, I will freehand this. You will use a ruler. Okay, so we can see here, this is our 2 lines. We always write what our equation is on the left or the side of it, so we know what one we're talking about, just so you have that available. Okay, so if we look at these 2, we can see our point of interest is going to be -2 and -3. And so therefore the solution to this linear system is going to be the same thing. Okay, because that is what our solving for the system means. So our linear system is also -2 and -3. Okay, then we can check our work. Okay, checking our work is always important. So in order to check that, we need to plug in our values. So we're going to separate, we're going to do 1 versus 2 over here. Don't mind the lines, it just kind of got wonky. So we're going to take our equations from previously, and we're going to do our left side. So our left side was y. That's a y, not a 4. Y, and we know our x and y values were -2 and -3 because that's what we said our point of interest was. So our y is equal to -3. And then our right side, we're going to plug that in. We're taking our equation, 2x plus 1. We're going to plug our values in. 2 times -2 plus 1. -4 plus 1 equals -3. So therefore, our left side does equal our right side, and we can check that off. Now, let's do the other side. Number 2, so x plus 2y equals -8. Okay, we're going to do our left side here, which is x plus 2y. We're going to plug in our values. So we have -2 plus 2 times -3. We're going to keep our -2 minus 6, and we'll get -8. And then our right side was -8, and therefore right side equals left side. Therefore, we know that our answer is correct. Okay, so that is a great example in order to understand how to graphically solve systems of linear equations. Make sure you're always checking your work. That's what I did there. I don't know why it's a little bit wonky, but that is a-okay. Alrighty, so we're gonna do one last example. Actually, I want you to try this on your own. One important thing to remind you of is to highlight, use the lesson information from yesterday. So doing your let statements are very, very important. I want you to try this out. The solutions are posted for this question, and let me know if you have any questions, okay? This is always great to practice these examples on your own and ask if you have any questions. I'll talk to you all during class, and let me know if you have any questions.